This poster illustrates the findings of an extensive exploration of governmental databases. The main objective was to find data inconsistencies within the records. To start, I'm going to explain the two databases used to perform the analysis. The Seguro Defeso is the artisanal fisherman's financial benefit, aimed to provide this class of workers with the necessary income in periods of which the fishes are reproducing, thus decreasing the predatory exploration of aquatic fauna. To support its population, the Brazilian government offers a high selection of financial benefits to complement the income of its lower economic classes citizens. Due to the sudden emergency of the COVID-19 pandemic, the federal government was forced to act quickly to minimize the negative impact that social distancing and quarantine caused in its population. Thus, the Auxílio Emergencial was born. Since most public services were unavailable, several steps were taken out of the benefit subscription forms to allow more people into the program, and with that, liabilities were overlooked and created. The analysis of this project consisted of finding fraudulent users' status and errors or differences in name records. The first cited financial benefit contains a criterion that the beneficiary cannot receive multiple benefits with the same NIS number, which is an identification number to register a citizen into the welfare program. In this project, the mentioned ID number was used to identify fraudulent users. For this issue, simply joining two datasets of the same month and year, each representing a different financial aid, is sufficient to detect the misuse of welfare. Now, for the second problem, HPCC was used to amass data in order to find as much inconsistencies as were possible. The first transformation the datasets underwent was selecting only a few columns and grouping their content to form cross-tables. The columns selected were staked in months, each with its own table. The former cross table was used for a geographic visualization of the frequency of users for each state. The latter for a historic series of total amount of funds spent on social welfare programs throughout the months since the beginning of the last month recorded of the exercise. The cross tables extracted from the databases could be used to rank which states of the Brazilian Federation have the highest inconsistency rate. That is, the number of observed inconsistencies divided by the total number of inconsistencies. To achieve this, it would be necessary to add one more field in the table transformation, including the federative state of the user. After the datasets had been appended, the meaning of the join transformation changed from detecting user irregularity to user inconsistency. To prepare the data for the joining operation, a couple of steps were taken to clean and extract meaning from the data. It was first transformed to include a record ID, and then applied basic transformations resulting in a sorted and deduplicated list in alphabetical order of both datasets. Each list contained the names of users and their respective NIS number, which was used as an input key for the join transformation. Lastly, the data was filtered to separate the resulting dataset in two conditions, one in which two names in the datasets matched and the other in which it did not. The main limitations of this work were the significant rate of zeros within the Auxílio Emergencial dataset, which limited join transformation. This could be dealt with by utilizing a less reliable but more frequent input key in the join statement, such as the combination of the name and the Brazilian Social Security number equivalent, the CPF. Another limitation was the hashed CPF, which limited the options of input keys in this operation, in the join operation. In conclusion, this project has found substantial amounts of irregularities within Brazilian government databases. The most relevant findings were a high rate of zeros, typing mistakes, and fraud. Due to the high amount of people attended by said benefit, mismatches in registration often create a high occurrence of fraud, costing thousands and millions of funds to the federal union. The next step to further improve the analysis are to develop a machine learning algorithm that identifies the inconsistency types so that solutions may be created according to the observed mistake.